Hi, hope you guys are having a great day. I wanted to share with you guys an activity that I do in my classroom dealing with chemical reactions and chemical changes. The title of this session is called Plop, Plop, Fizz, Fizz, Oh, What a Chemical Change It Is. My name is Stacy Thibodeau. I teach Chemistry 1 and 2 in South Louisiana at Southside High School. And I really enjoy teaching chemistry. I think it's probably my favorite subject I've ever taught. I really like doing the hands-on labs with students, but as we know in this day with the new guidelines, we might not be able to do the labs or we might be in a virtual or hybrid situation. So I was looking for solutions to actually be able to still do some of the same types of activities with my students, but in a simulation, and I came upon this activity. So I hope you like it. I teach in Louisiana, like I mentioned, and we are an NGSS newly adopted state. We're not an NGSS state, but we adopted new standards. And so I really try to model all of my lessons using three-dimensional learning. And so this activity hits the MSPS 1-2 standard, which is to analyze and interpret data. So we have to have some data on properties of substances before and after it comes in contact with something else to determine if a chemical change actually occurred. So our main science and engineering practice is going to be analyze and interpret data, but you're going to see throughout the activity, I actually pulled in a couple more. The DCI, or disciplinary core ideas, have to do with pure substances with physical and chemical properties. And then when we have a chemical change, we can regroup how the atoms are rearranged to form different properties. Cross-cutting concept is patterns, both macroscopic and microscopic. For those of you in Florida, this is under the big idea 9, changes in matter. We know matter can undergo a variety of changes physically and chemically, and we definitely want to see if something happens with a chemical change, we end up with new substances and new properties. So how do we know chemical changes occurred? So I like to use the 5E model of instruction for my classroom instruction. And so I'm going to model a sample lesson that I do with my students. We're going to do some kind of engage. We're going to have an explore activity, an explain. We're going to do an extension or an elaborate, and then some type of evaluation. So phenomena-based instruction, if you are new to science or new to the changes that have happened, phenomena-based instruction should be where you're headed. And so we use some type of overarching theme or phenomenal observation that has happened in the environment. And then we use it to hook the students. And so for this, my phenomenon is the fact that the Statue of Liberty has changed in color over time. And so when we first got her in 1886, you can see in this top picture, she really was a copper color. And then over time, this is a picture from 2018, she's now green. And so why has she changed? If nothing has happened and we haven't done anything to her, no painting or anything, why has she changed? I have a research article over here on acid rain pollution. It might be something if you wanted to have students to do some scientific literacy skills in your classroom. And then I would have students come up with a driving question board. And this driving question board helps students to see the phenomenon and where you're headed. And they also have ownership in some of the content delivery. So why did she change colors? What was maybe in the air that caused this change? And can we prevent it from happening even more? So the simulation that we're going to use for the explore activity is called chemical reactions. It comes from Texas Instruments. And I'm going to show you the website in a second. If you have an iPad, you can actually run it on the iPad too. I'll show you that as well. And so this is just a screenshot of the actual activity. Over here, I have the activity files. They are completely downloadable, and you can download them and change if you need to. So this is TI's website. If you go under activities, science-inspired activities, and this is under physical science, properties of matter. In the slide deck, I have them all linked. And this is under evidence of chemical reactions, go figure. And so when I click on this one, you can actually preview and see if this is something you want. There's a TNS file, which is the TI-Nspire activity file, which we'll see run on the simulation. There's a teacher's notes page that I would definitely download. It gives you some great tips and tricks for using the technology, but also delivery of the content. a student activity PDF, and a student activity doc. The student activity doc page is completely editable by you. You can change it, add it, put it in your learning management system, whatever you may want to use, which makes it easy for you to have the students to use. So I said I was going to show you how I use the iPad. And so this is my iPad. I have a computer connect server where I can show my iPad as I'm walking around the room or doing virtual learning. And so I downloaded the activity to the iPad, and I'm going to do the exact same thing that I'm going to do for you in a second with the teacher software. So I can add a reactant, and I'm going to put it with some type of liquid. Pick it up, put it in there, and observe. This one says no reaction between chemicals. Everything that I was able to do, what you'll see in a second, on the teacher software version, I'm able to do on the iPad. So if you have an iPad and that's something you're interested in using, it is available. So I'm going to show you how it looks on the teacher software. So this is the TI-Nspire CX Premium Teacher software. This is what the calculator face looks like. And you can click up here to move from page to page. And so what I just did, we saw an example of the baking soda with the hydrogen peroxide. Let's put zinc, and let's start with hydrochloric acid. So why would I use a simulation over using the real thing? So one is safety. In this day and age, we don't know if we should have our typical labs with students so close to be able to observe and see these demonstrations. Two, teachers might be in virtual environments where they're teaching part-time with hybrid or completely virtual like you and I are doing. And so with that, this simulation still allows for students to have access to real chemistry, adding zinc with a chemical, but in a simulation setting that allows for safety. And so when we put the zinc in the hydrochloric acid, we saw some bubbles. We also saw that temperature increase. And so for me, I would have my students, this is an Explore, I would have them write down what did they see that they think could be evidence of changes. And so you can try all of the different solids with each of the liquids. I'm going to go do some baking soda in hydrochloric acid. I put baking soda in hydrochloric acid. I see it's bubbling, but notice the temperature is actually dropping. And so a lot of students think that evidence of a chemical change is that heat is released, and we know that it's not. A temperature change can be. One of my favorite for this activity is with sodium. We know sodium in some schools, you can't have it. It's very dangerous. But to show the reactivity of the alkali metals, which alkali metals are in column 1 and sodium is one of those, to show that how reactive they are, you want to have some kind of a demonstration. So for me, this is like the safest way to show sodium in water. Put my sodium in water and kaboom. It's so reactive, it actually breaks the glass. And any of the water liquid solutions that you put sodium in, it actually will do that. Well, let's do one more. I'm going to do luminol because I think luminol is pretty cool. Put luminol in hydrochloric acid, and I put some luminol. There's no reaction. Let's try some luminol in hydrogen peroxide. So this is 30% hydrogen peroxide. This is not the same hydrogen peroxide strength that you would buy from like a drugstore. This is what you would have to get from a beauty supply store. So when I put the luminol in here, it glows. So you can talk about properties of what are some properties of chemical versus physical changes. And the activity, you could take some of these questions. If you had students in the classroom and they had the handheld calculators, you could send them the questions and they could answer them and you could collect it from them, a formative assessment tool. If you're in a virtual situation or environment, maybe you have them jot it down in a Google Doc, or you create a Google form, or whatever your learning management system platform is. So there's some great questions in here that are thought-provoking, but also make it so that students can answer and kind of give some feedback and reflection on what they just saw. So that would be an Explore activity for me. And so to go on from that, I would do an Explain. So I use digital notebooks in my classroom. Before this year, everything was paper pencil. There's a lot of studies out there that still believe that students should be writing. And so we use digital notebooks. This is through a program called Class Kick that I use. And then we would jot down each one of the reactions and what did we observe and classify it, whether it's chemical or physical. And that would be my explain part. For elaborate or an extend, I would probably do this lab simulation. If the teacher has a document camera or wants to do a recording like I'm doing, this is called reaction in a baggie. It comes from Flynn Scientific. You can find the instructions real easy. I did link them in here, or if you just find a video from Flynn. And so it takes two different solids and a red liquid, and you put them into the bag in each corner and the liquid in the middle, and then you mix them, and this is what you get. And so you could then have the students, this is elaborate, and evaluate them on what they learned about chemical and physical changes. A gather reasoning communicating type tool or a claim evidence reasoning, but you can hit the SEP of engaging an argument from evidence if you do these types of evaluations. And then lastly, part of this activity, which we didn't see just yet, is that there are some questions embedded about balancing equations. And so after you teach the students about chemical reactions and chemical changes, we could then explain to them law of conservation of matter and why we balance these equations. And so the students can edit the formula, or you can. And then again, there are some questions that are embedded in here to give students a walkthrough example of how to do that. So I included some different resources that I use for this presentation, but also to keep me up to date on current science practices. Gave you the information about Texas Instruments website if you should want more information on how I downloaded the activity. And then again, this is my contact information if you want to know more how I add more of this into my classroom. This school year, I teach both face-to-face and virtual hybrid. So I'll be more than happy to share anything with you guys. And maybe just follow me on Twitter and see some of the cool things that I'm doing with my students. Take care. Bye.